Okay, this video is going to go over properties of exponents. It's meant to be a refresher video, so if you really don't have any clue how to do this, you might want to find a different video because I'm going to be going kind of fast. All right, I'm going to start with number 15 here. Let's just tackle the zero property rule. It says 7c to the 0 plus 3c to the 0. Okay, you need to realize anything to the power of 0 has a value of 1. So like this right here has a value of 1. This 7 is not included. It has its own exponent. So this is really like 7 times 1 right there. And so if you look at the second one, this is grouped to the power of 0. So the whole thing becomes 1. So the answer to this one's 8. So if you see something like this, it's grouped to the power of 0. That means the whole thing is 1. I hope that made sense. Okay, let's keep moving. Now, just go ahead and look at number 1. Negative exponent rule. If something has a negative exponent, you have to imagine it as a fraction, and it has to go to the other side of the fraction. So now there's nothing on top, right? And it becomes a positive exponent like that. So this one would be 1/8. So like, look at number 5 now. You have -8 x -3. The biggest mistake people will do here is they group this all as a -3 exponent. That's not the case here. The -8 has its own 1. And so really it's just this x -3 that needs to go to the other side of a fraction. So it's going to be -8 on top and x +3 on bottom, just like that. It works the same way too, even if it's already on the bottom. Like look at 26. You have 1 over x to the -3. All right, this is a power to power rule. We'll get to that in a sec. But basically what's going to happen is the top and bottom are both going to get these exponents. And so now that they're negative, they need to switch places in the fraction. So like this one would become x cubed over 1 cubed, which is just x cubed over 1, or just x cubed. So the negative exponent rule is really, really important, like number 9 here. Sorry, I'm kind of jumping around, but all right, say you have a negative exponent times something with a positive exponent. Well, you need to realize that you're adding these. And so like this one is going to be C2. Look at 19. -5x5 times 2x -3. Okay, realize that the 5, or the -5, sorry, and the 2 have the exponent 1. And so these numbers you just multiply, -10. And then these numbers you are adding, so x2. All right, now look at 12. You got 3y -1 times 6y -2. We'll do the 3 times the 6 first. That's 18. And then you're adding the exponent on those y's. So you get y -3. But you're not done because you're not supposed to have negative exponents. So the 18 has a 1. But this y -3, it's got to go to the other side of the fraction. So this answer would be 18 over y +3. All right, now let's look at some power to powers, like 28. You got r -3 over s to the -1. Okay, power to power is the only time you multiply exponents. See how it's a power raised to another power? So you're going to be multiplying. And yes, they're both going to get it because they're both grouped in this parentheses. So this one's going to look like this. R +3 on top now. s negative 1 on bottom now. But again, you're not supposed to have negative exponents. So like this guy's going to come up here and he's going to become r cubed s1. And you could put over 1 if you want, but that's not really necessary. Let's look at another power to power. Let's look at a more difficult one like 37. Okay. This is a power to a power. So I'm going to be multiplying all these exponents by that negative 2. Go ahead and give the y its 1 on bottom. And so you're basically distributing this negative 2 to all these exponents. And so when you multiply, you get x6, y8 over x4, y negative 2, which brings us to basically the last rule that we're going to talk about, which is when something's over something else that has the same base. All right, so before I even do that though, I don't like this y negative 2. I'm going to send him to the top and he's going to become y positive 2. So I have x6, y8, y2 over x4. Okay. So this right here is going to make y10. So I know I have y10 on top. And now when you look at these x's, basically you're just subtracting, or you can kind of think of it as which one's bigger, the top or the bottom? In this case, the top is bigger. By how much? By 2. So this would be my answer, x2, y10. Let's look at a couple more. Look at like 42. Okay. There's no technical negative exponents here. They have binomials as their exponents. So basically, you're going to stick to the plan here, and you're going to be subtracting these. So like this, you're going to be subtracting. So it's really like x to the 2n minus 1 minus n plus 4, like this. And the y's, it would be y to the n minus 3 minus n plus 3. All right, so you're going to have to distribute this negative. So it's going to make like plus negative n minus 4. This one as well. So it's going to make like plus negative n minus 3. Then you can just combine your like terms there. So I've got 2n plus negative n. Well, that's just n. I've got negative 1 plus negative 4. Well, that's negative 5. And then for the y's, I've got n minus n. Well, that cancels. And then I've got negative 3 plus negative 3. That makes y negative 6. And so I would basically be done, except this right here, now it does have a negative exponent. So it's got to switch places. So my final answer here is x to the n minus 5 over y6. Okay, let's look at one more. Let's do a difficult one like 46. Give me a second to write it out. Okay. So here we go. I've got two things and they both have a power to a power. See, power to a power. So that's what I'm going to handle first. I'm going to go ahead and distribute power to power to everything. So like give the 9 its 1, the a its 1, the 8 its 1, the b its 1, and then they all get times by this negative 2, top and bottom. So it looks like this. 9 negative 2, a negative 2, b4 over 8 negative 2, a4, b negative 2. Let's just handle this first part. Ignore this guy for right now. All right. Anything with a negative exponent is going to switch. Like this, 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 this. It's all going to switch places. So 8 positive 2 on top. We had b4 there. That's this b4. Well, now a b negative 2. This guy's coming up, so he becomes b positive 2. And on bottom, now we have that 9 positive 2. We have that original a4 And then we have this a negative 2 that's switching places. So really we have 64 b6 over 81 a6. That's this whole thing when you break it down. All right, now I'm going to do the same thing for this this other one. So you're going to get like 3 cubed a negative 6 b3 over 2 cubed a6 b negative 6. I'm going to move everything with the negative exponent. Like this a negative 6 is going to the bottom. So it's going to turn into 3 cubed b3 b6 over 2 cubed a6 a6. So really, when you think about it, you have 27 b9 over 8 a12. All right, so now we're here, and we're back to multiplying these two things. I like to cancel and reduce before I multiply it out. So like I would not be multiplying 27 times 64. I would be reducing the 8 and the 64 as I went, and I would be reducing the 27 and the 81 as I went. So on top we had 8, b6, b9 makes b15, and on bottom we have 3, a6, a12 makes a18. So this would be my final answer. So yeah, well, let's go ahead and look at 47, just in case. This one will be quick. X, y, negative 2 cubed to the negative 2. All right, it's just a power to a power to a power. So you're just multiplying this, but it's just more than one time. So like the x has a 1, I'm distributing a 3, so you're going to get x3, y negative 6. Now at this point, I don't move negative exponents yet because I still have another power that I'm going to, that negative 2. So I do the next power to a power again. So it turns into x negative 6, y 12. And then at the end, you just move that x negative 6. So it becomes y12 over x positive 6. All right, so I hope this was a good refresher for your exponential properties. We'll be actually solving in the next video, but I hope this video helped.